So, Stephen, you are a reader in cosmology,
Yes.
but you're also head of astronomy here at the Open University.
For my sins, yes.
So could you start off by telling me a little bit about your research, how you got into that area, and why we're standing in front of a big rock?
Right. Well, this is no ordinary rock. This fell out of the sky. This is an iron meteorite. And to me, it is genuinely amazing that you can touch something that has come from outer space, and you feel it. It's heavy.
Yeah, it
it's
is.
just humongous. Now, from a solar system astronomer's point of view, they will think of this as an iron meteorite, but to me, as a cosmologist, this is an example of the sort of things that would count as baryonic dark matter. Okay, and so things that don't emit light, but are floating around there in space, and we know that they're there, but it's very hard to know what they are. You know, it's iron and the carbon and water and whatever that we're made of, and the protons and neutrons that make up all of the everyday objects that are around us. But most dark matter in the universe is not baryonic. It's not made of the protons and neutrons and whatever else that we are made up of, and everything that we can see are made up of. It's something completely different. But it's very, very hard to detect. And that's the sort of research that I'm interested in.
And have you found any dark matter yet?
Loads and loads and loads. And we've found it from the warps in space and time. And that's the sort of thing that I do. So if I had really good eyesight, I'd be able to see something just skimming past you, and I'd be able to see it kinked slightly. And that kink would be because I'm looking through the warped space that you're creating around yourself, right? But we are too small. We're not massive enough to see these warps in space and time. But if you're a galaxy, then you can see the warps.
Because galaxies are enormous.
Because galaxies are vast, that's right. And so that's what I look for. I look for these chance alignments of galaxies where you've got a foreground galaxy warping the space and time around it, and a background galaxy, and we just look through, just past the foreground galaxy, and we see this warp. And it's an amazing thing, and it's a tremendous time of discovery right now in astronomy. It's exactly the sort of stuff we do at the Open University. And it's also what we try to integrate into our undergraduate curriculum, because I am a passionate believer that this is what an undergraduate degree should do. You should have some interaction with the cutting edge of research. It's what universities are for. And so this has to be part of our undergraduate curriculum, that you use world-class space telescope data and professional software to learn about how the universe works. And in fact, here's an example of an image from the Hubble Space Telescope, and it's the sort of image that we work with in our undergraduate curriculum. And it's just very beautiful. It's just gorgeous. It's a dust cloud.
It's not dark matter, though, is it?
It's not dark matter. It's a dust cloud where stars are being born in our galaxy. And it's the sort of thing that we get our undergraduates to work with in our curriculum.
So your research focuses on dark matter.
Mm-hmm.
Has there been any kind of exciting developments in that field? Because we seem to have been hearing about it forever.
We have. Well, in fact, at the Open University, we had a breakthrough in this area. And it was very, very exciting. We were looking for galaxies with a telescope called the Herschel Space Observatory. And we found that there were some galaxies that appeared much, much brighter than seemed reasonable or possible, or even physically plausible. And it turns out that they were bright because they were being seen through a foreground warp in space and time, and it was magnifying the galaxy. So we see these hugely bright galaxies, they're very, very rare systems. They're dotted across the sky, but they are the places where you have this chance alignment of two galaxies. So we found that using the Herschel Space Observatory, we had a fabulously efficient way of finding these chance alignments and these warps in space and time.
And that's where the dark matter is.
And that's exactly where the dark matter is. And we can see it where there are these chance alignments. And it was very, very exciting. It's part of this revolution that is happening in gravitational lensing right now. And it is certainly something that is part of our undergraduate curriculum. So this is something you learn about in our final level astronomy program.
So that's your research and teaching, but the Open University is famous for its open educational resources online. Are you involved in that side of things at all?
And some things. It's one of the marvellous things about being at the Open University is that we have this open education mission, and we create all of these resources, and it's just fabulous. So, for example, one thing that I've been involved with are the 60-second adventures. So these are 60-second cartoons, animations, where we explain a complicated physical phenomenon, but we do it with gags, basically. So this is David Mitchell is narrating them, and they've been humongously successful, and it's been so much fun working on this. And I don't know, lots and lots of things. So we do BBC broadcasting, we have blogs and videos and things that we connect with that, and now we're interested in the International Year of Light, which is suddenly taking off. And we've got blogs and videos and things that are associated with that. So it's really, it's fabulous at the Open University in that we create all of these open educational resources. So you don't need to be studying a degree to be benefiting from the Open University.
Stephen, thank you. It's been lovely to hear your passion and enthusiasm for your subject.
All right, thank you very much.